and they lose less power. So all of these are good reasons. And why there's less energy power lost there, that's a pretty tricky thing to explain at this level, and you wouldn't be expected to know it, but you just need to know at this stage that less energy, less power is lost along the way. If you do physics next year, then we'll go in a little bit more in detail into why that is true. And I've gone over the time limit, so I'm going to have to cut this video in half later. Anyway, so I'll continue with part C. Part C says that a power station produces electricity at 25,000 volts, which is increased by a transformer all the way up to 400,000 volts. They then say that the transformer has 2,000 turns on the primary coil, so the primary coil has 2,000 turns. Okay, if you haven't looked at the theory on transformers, then go and do that either on the book or on one of the videos, and then come back to the question. It's very easy to do the questions, but you need to know what's going on in order to do them. So they tell us the primary coil has 2,000 turns, and so that they give us even the formula. How nice is that? They say use this formula, which is that the voltage across the primary coil divided by the voltage across the secondary coil is equal to the ratio of the turns, right? So the number of turns on the primary divided by the number of turns on the secondary. So that's really handy. If they give us the formula, then we only need to know how to use this in order to work it out. So they're telling us they want to go from 2,000 to 400,000, and this is the primary coil with 2,000, right? So you can come here and say, well, then 25,000 volts to 400,000 volts, sorry. So 25,000 volts is in the primary volts, divided by the secondary. They want to get 400,000 in the secondary. That needs to equal the ratio on the primary, which is 2,000, divided by the number of turns on the secondary. And this is what they're going to ask us about, I suspect. Let's see what they say. They say calculate the number of turns on its secondary coil. So that makes sense. We want to find out this guy. So we need to do some algebra and make sure we don't make any mistakes. So how do we do the algebra on this? Well, I'm going to do it with normal letters. So let's say, imagine that this is one letter, and this is another letter, that's another letter, and that's another letter, and we're doing it in normal algebra. So then what this really says is that x divided by y is equal to z divided by r. Or actually, I'll call this one n, since it's really what we want to find out. And we want to find out this guy here. Okay, so what does this look like? Running out of space down there, I'll do it on the side. Well, if x over y is z over n, and I want to find out n, first thing I need to do is to put this n on the top somewhere, because now it's on the bottom and that doesn't really help. I want it on the top because I want at the end of the day I want n equals something here on the right, and the n is on top here, it's not on the bottom, it's not 1 over n or something over n, it's just n. So another way of thinking about n, that's n divided by 1, so it's actually on the top of a fraction. So I need to move around this n to the top of a fraction. The first thing I need to do to both sides of the equation is to multiply by n. Right? If I multiply the left side of the equation, all of this by n, then I get n times x over y. I multiply the whole of the left by n, and on the right, if I multiply all of this by n, then it disappears from the bottom, because n divided by n is 1, and then I have z divided by 1, so then I get, or z times 1, so then I just get the z. right? So all I've done is I've multiplied by n both sides here and here. If I multiply a fraction which has a number at the bottom and I multiply it by the same number at the top, then this is the same thing as doing that. 1 times n, n times z, and then n divided by n is this, they just cancel. So here I end up with a z on the right. And now I need to pass this fraction to the other side. So I'll do it, instead of doing it in one go, I'll do it in two parts. So first let me rewrite this. When I multiply a number by a fraction, I can just write it down like this, right? It just multiplies on the number on the top and the bottom stays as it is, because n is the same thing as n over 1, so 1 times y is y and n times x is nx, right? So nx over y is equal to z. I haven't changed on the, I haven't done anything to this side, I've just rewritten it, so I don't have to do anything onto the z. Now we now want to move the y so that we can have a more simple equation. The y here is dividing, so if we multiply both sides of the equation by y, we are going to end up with nx on the left, the y disappears, and on the right we have zy. Okay, another way of thinking about it is that you're just passing the y to the other side. Here it's dividing, so it goes multiplying, but really we're multiplying both sides by y. So we're nearly done. We've got an x equals zy, and now we want the n alone, so the x is annoying us and the x is multiplying the n, so if we divide by x we get the n alone, and we get to do the same thing on the right. So that happens. So then we're finished. N is equal to z, y over x. Now we need to go back here and say, okay, what was z and what was y? Well, z and y were this guy and that guy. So z is 2000. So then n is equal to 2000 times y, and y was 400,000. 400,000, and I need to divide all of this by x, and x was 25,000, right? This guy at the top, 25,000. 25,000. I prefer to do all of this with letters, and then I can do it at the end. I can put in the numbers, and that's easier than writing 2,000, 400,000, 25,000 all the time. So let me do this in the calculator to see what I get. I just did it, and it came out to 32,000 turns. Okay, so 32,000 turns is the number of turns that I need on my secondary coil in order to step this up. So in other words, if I do 2,000 divided by 32,000, I'm going to do that in the calculator just quickly. 2,000 divided by 32,000, I get 0.0625. So I get so this guy here gives me 0.0625. that's my decimal, and that should be exactly the same as the ratio of these two guys here, the voltages. So if I do 25,000 divided by 400,000, I get, yes, 0.0625. So I've used the maths correctly, and this formula works, and so it's all good. And the number of turns I need is 32,000 turns to step the voltage from 25 to 400,000. Okay, so hopefully that makes sense, and I'll see you in the next video.